Handcock, and I'm a data scientist working at Curtin University. Now, we've been hearing a lot about data science, better slide there, with the recent discussions about AI. Now, data science is not all sitting around chatting with your AI robot friend, although I know a few of you in the audience probably do that. So what I'm going to do today is tell you about what a data scientist does. Now, I didn't start out life as a data scientist. I started out life as a geographer. So the problem is, no one knows what geographers do either. Geographers basically study maps and things that move across space in both the sciences and the humanities. So basically, geographers are the new Renaissance people. And I bet you didn't know that there was a picture of me about that. The type of geography I do is mostly in the sciences, so mostly dealing with satellite data. This is a satellite image from space, which is basically like a photograph, and I'd like everyone to wave because we can see you in the image now. Yeah. There you are, right there. So I use satellite data to study vegetation and water, and I study mostly agriculture, looking at dairy and cow pastures. So we get asked a lot, do we actually count sheep from space? And well, we used to, but all of our research scientists fell asleep. So we ended up saying we just need to do it really using satellite data. Now, for those of you who think that your day jobs are pretty boring, imagine this, for 10 years I did nothing but watch grass grow. And this is actual footage from a real research farm here in Australia. Now, during all that time, I realised something about myself. I realised that I love data, like really love data. Like, clear my browser cache. In fact, I like data so much that I pivoted into being a data scientist. Now, let's talk about that a bit. People think that data science is basically like this, and this is what I do every day. Actually, this is what I do. I deal with a lot of software, data, statistics, and so on. Now, when we look at data science, we essentially are talking about three things. We collect data, we analyse data, and we present data. And we do this to answer questions. Actually, we need to answer questions in research because I'm a data science working in research. So let's use an example to go through this. So we have to start with a question. So imagine I'm sitting there in an office, minding my own business, and a researcher walks in and says, Dr. Handcock, have I got a question for you? I'd like you to answer with some data. Fantastic, I say. What would you like to know? I would like you to use data to find out which animal on the planet has the largest penis. What an interesting question, I say, as I giggle to myself quite a bit. And as we are scientists and not smutty teenagers, I think, well, let's get in and see how we can work out some data about this. After that data science interrupted us, I would like to continue now with talking about data. So we have different types of data that we can collect, which answer our research question, which if you recall is which animal on the planet has the largest penis. Now, the question is, what's data? Data, as we recall, is anything that is a measurement or something about the thing we're trying to study. So for example, we have numbers. So numbers are one type of data. For example, we have length. We also have other types of data, which are numbers, in this case weight. So not all data is numbers though. We can have text-based data. For example, we have here and we can also have anecdotes or maybe video, but I'm not allowed to show that here today. But one of the things about data is it needs to be collected ethically, and it's very hard to get data on this topic. So I'd like you to all know that I'm going to be running a citizen science project. I've got some measuring instruments, rulers, calipers, protractors. During the break, come and see me at the table outside, any of you who'd like to participate. So let's say we've got our data. What do we do next? We analyse it. And analysing data is where we essentially try and turn data into information. So hands up if you've ever had a Lego pile like this. Yeah, most of you. It's a bit of a mess, you can't make sense of it. Well, think of each piece of Lego as a piece of data. It has different colours, lengths, number of knobs, this sort of thing. And what we need to do is clean the data. And cleaning data is where you make sense of it. You organise it, you see how many are there, you put it into categories. Basically, being a data scientist is 80% of data cleaning. And all the cool stuff you see with AI is pretty much cleaning data behind the scenes. So, at home, I clean my house. At work, I clean data. But I can't show you a third one because when I Google cleaning penis data on my work laptop, I got a call from HR and So once we've finished analysing our data, the next thing we need to do is present the data. Remember to answer our research question. And the best way of doing it is to present the data by telling the story. Now, to do so, one of the things we do is data visualisation, which is where you actually get the data you've collected and present it in such a way that we can all see what's going on, like we have here with the Lego. Also, you can tell it with a story because you're trying to answer a question with the data you've got. Now, let's go back to our question, which was which animal on the planet has the largest penis? Well, the answer is it's the blue whale, which has a penis of 3 metres in length. Now, just so you know, that's the reason if you go to a bar on Saturday night, if there's a blue whale there, you're not going to have a chance. So what do we do if we can't get data? And based on, I haven't really been having many sign-ups for my citizen science project before yet, although there's still time. What we do is we get data from what we call published science. So what does this mean? Other data scientists, or scientists in general, researchers, they present their findings from their research in scientific publications. Now, these are basically magazines for scientists, and pretty much that's what we do. We do research and publish it in papers. Now, there's a few problems here, because when we look at how science publishing works, it's something that I like to call big publishing. Big publishing works like this. Scientists and researchers are paid by their job to do science. They then pay the publishing company to publish their journal articles. The publishing company then charges scientists to read the journal articles that they've given them for free. Now, if that doesn't sound like a pyramid scheme, I don't know really what is. And the thing is that journal articles are expensive. I looked up one of my articles this morning. If you want to read it, it'll cost you $60. Or you can ask me, I've got one that fell off the back of the truck. And so the publishers are making a lot of money from this. And so people said, hey, is there a better way of doing this? And they came up with something that's called open access, which is they said, how about we publish scientific articles in a way that means people can read them for free? Which really sounds like a fantastic idea compared to giving that money to the big publishing companies. And that's what they did with open access, which is the area I work in. So, to find these articles, you need to work out where they are. And how we do that is with something that's called a citation index. Basically, this is just what it looks like on the picture, which is this huge index of all the research articles ever published, whether in sciences, humanities, wherever. And these indices have been around for a long time, and the problem with them is that they mostly index science and other research that's published in English, that's published in very rich countries, what they call the global north, and they're super expensive. So not only do you have to pay to get your journal articles, you have to pay to access these indices. So people I work with thought, well, that's not such a good idea. Let's see if we can do something about that. And so I work with an amazing group of people that said, let's get all the freely available information on publications, this citation information, let's get it all together, clean it up, get it to talk to each other, and then censor it, which is actually quite bad. And we get it all to talk to each other, and then we can combine it to do some really good. And the data set that we have has 153 million research articles, which is twice as big as the commercial publishers. And not only this, it's free, it covers other languages more extensively, and publications from different parts of the world that the commercial ones don't cover. So basically it's a really good thing. Now, what's interesting about this is that our data set goes back to the medieval era. We have publications going back to the 1300s. And back in that era of illuminated manuscripts, books were really expensive, so they used to chain them to shelves when they were in libraries. Now, I think this is coming full circle because we've gone from books being chained up to open knowledge and everyone around the world having access to this information, which is a really good thing. Now, let's go back to our question. As I said, we can look at published data to answer our question. And I did this. I had a look at our whole data set. And what I found is that there were actually only 78,000 articles on penises in the entire scientific literature. Oh, there are only 19,000 on human males. And I've got to say, that was a lot smaller than I expected. So, I got thinking about this, and I went, okay, you know, that's mildly interesting. But Jane Austen, now that's what I'm really interested in. And there were just over 10,000 articles on Jane Austen, and this is in our actual databases. Now, I thought, let's get into this a bit more detail, and let's look at it over time. And I don't know how to explain this. We have over time, in the last 2 decades, about a decade ago, there was a massive increase, a sudden rise in the number of articles that were about human male penises. Whereas Jane Austen just kept ticking along. I don't understand that, but I'm sure there's a story there. So, I would like to finish with, there's a quote from the Wall Street Journal that says, data science is the sexiest job of the 21st century. Now, we're at Fringe, so I would like you to come back later because I'm going to have a crossover burlesque comedy show called Data Science After Dark. And there, you can watch me playing some dirty, dirty data.